Take a deep breath. Wherever you are, I want you to look up. Even if there is a ceiling above you, imagine the vastness beyond it. You have found your way here tonight for a reason. Perhaps you are settling into bed, the day finally behind you. Or maybe you are somewhere quiet, seeking a moment of peace before sleep finds you. Wherever you are welcome here. Tonight, we are going to explore a question that is both scientific and deeply poetic. A question about time and light and the fleeting nature of beauty itself. Are we living near the brightest moment of the universe? Let that question rest in your mind for a moment. Do not try to answer it yet. Just feel its weight. The brightest moment. Not the beginning of time, when the Big Bang filled the cosmos with energy. Not some distant future we can barely imagine. But now, we're somewhere very close to now. A brief middle age in cosmic history when the universe shines more brilliantly than it ever has before or ever will again. Think about the stars you see. A handful of scattered diamonds or the full sweep of the Milky Way. Most people think the universe has always been this bright. But the truth is much more haunting. We are participants in a cosmic story that has a very specific peak. And you, listening to this right now, might be witnessing the final great gala of existence. If this kind of exploration speaks to you, consider subscribing. It helps others who need this quiet space to find their way here too. But there is no pressure. For now, you have nothing to do but breathe, settle deeper into comfort, and let your thoughts drift with me into the deepest mysteries of light and time. So take another slow breath. Let your shoulders drop. Feel the surface beneath you supporting your weight. Notice the subtle rhythm of air moving in and out of your body. That ancient pattern that connects you to every living thing that has ever drawn breath under these same stars. Tonight's question, are we living near the brightest moment of the universe, is not as simple as it appears. Because what does brightest even mean when we are talking about the entire cosmos? It could mean the moment when stars are being born at the fastest rate, when galaxies blaze with the fever of formation. Or it could mean something quieter, something about accumulation. The moment when the most stars exist at once. When the night sky, if you could see all of it, would be fuller than it has ever been or ever will be. These are different ways of measuring brightness. And they peak at different times. But somewhere in the middle, in this strange and temporary present we inhabit, they overlap. That convergence of light makes our moment in history something rare and precious. A golden hour, not just the brightest instant, but the brightest era. A window of time, barely a flicker in the full span of cosmic history, when the universe is at its most luminous and its most alive. And we are here, right now, breathing and thinking, part of this fleeting cosmic noon. But to understand why this moment might be special, we need to step back. We need to see where we came from and where we are going. We need to understand that the universe has not always been bright. In fact, for a very long time after the beginning, it was darker than we can easily imagine. And in the far future, long after we are gone, long after every civilization that might ever exist has faded, the universe will grow dark again. Darker than it is now. Darker, perhaps, than it has been since those first long ages after creation. The brightness we see around us, the stars in the night sky, the galaxies scattered through space like islands of light in an ocean of darkness, all of this is temporary. It had a beginning, and it will have an end. We live somewhere in between. Think about that for a moment. Everything you associate with the universe, stars, galaxies, the soft glow of nebulae, the distant shine of quasars, all of it exists only in a narrow window of time. Before that window, there was darkness. After that window, there will be darkness again. And we, impossibly, improbably, happen to exist right in the middle of the light. This is not something we often think about. We look up at the night sky, and it seems eternal, unchanging, a backdrop that has always been there and always will be. But cosmology tells us otherwise. The universe is not static. It is a story unfolding across billions of years. And like any story, it has chapters. A beginning where things are simple and dark. a middle where complexity blooms and light fills the void, and an end still unimaginably far away, where everything settles back into silence and shadow. We are in that middle chapter, and if we are very lucky, if the timing has worked out in a way that is almost too perfect to believe, we might be living in the paragraph where the brightness peaks. The sentence where more stars shine at once than at any other moment in the history of the universe. Isn't that extraordinary? Not just that we exist at all, though that is remarkable enough, but that we exist now, in this particular slice of time, when the cosmos is at its most radiant. When the stage is fullest, the lights are brightest, and the show, if you want to call it that, is at its peak. Of course, we cannot know for certain. The universe is vast, and its timescales are almost incomprehensible. But the evidence, the data from telescopes and satellites and decades of careful observation, all of it points to the same conclusion. Star formation peaked billions of years ago. The rate at which new stars are being born has been declining for a long time. But the total number of stars, the accumulated light of all those births across all those billions of years, that number might be reaching its maximum right now. Or it might have just passed it. Or it might still be slightly ahead of us. We are close, very close, to the brightest moment. And that means something. It means the night sky you see, or the night sky you imagine, is as full as it will ever be. It means the galaxies we observe through our telescopes are as numerous and active as they are ever going to be. It means we live in a universe that is, in a very real sense, at its peak. Not its beginning, not its end, but its fullest, richest, most luminous moment. There is something both wonderful and melancholy about this, isn't there? Wonderful because we are here to witness it. Melancholy because it means the decline has already begun, or is about to begin, or in cosmic terms has been happening for so long that we are already on the downward slope, even if we do not feel it, even if the sky still seems full and bright and endless. But we will sit with that melancholy later. For now, let us just appreciate the wonder. Let us appreciate that we exist in a universe at its brightest, in a time when light fills space more abundantly than it ever has or ever will. Let us appreciate that the stars above us are not eternal fixtures, but participants in a grand arc of cosmic evolution, and that we happen to be alive at the moment when that arc reaches its highest point. Take another slow breath. Feel yourself settling, sinking deeper into this moment, this present, this now. Tonight, we are going to walk through that arc together. We are going to start in the darkness, before the first stars formed, and we are going to see how the universe learned to shine. We are going to witness the peak of star formation billions of years ago, when galaxies were forging suns at a rate we can barely comprehend. We are going to arrive at now, at this moment, and ask whether the brightness has faded or whether it is still climbing. And then we are going to look ahead, into the far future, and see what happens when the last stars die and the universe grows cold and dark once more. It is a long journey, but we will take it slowly, with pauses for breath, for reflection, for letting ideas settle like snow on a quiet night. And by the end, you will have a sense of where we are in the story. You will know whether we are living near the brightest moment. And perhaps more importantly, you will feel what it means to be here, now, in this brief and luminous window, while the lights are still on and the universe still shines. The stars are waiting. The story is waiting. And we have all the time in the world, at least for tonight, to drift through it together. So let us begin. Let us go back to the beginning, to the darkness that came before the light, and watch as the universe, slowly, patiently, and possibly, learn to glow. In the beginning, there was light. But then, for a very long time, there was darkness. This might sound strange. We are used to thinking of the Big Bang as a blinding flash, an explosion of energy that filled the universe with light and heat. And that is true, in a sense. But it is not the whole story. Because the light from the Big Bang, the light that we now see as the cosmic microwave background, did not last. It could not. As the universe expanded and cooled, That light stretched, reddened, faded until it was no longer visible to the eye. And what was left, after that initial glow dimmed, was darkness. Not the comfortable darkness of a room at night, where you can still make out shapes and shadows, but total darkness, absolute darkness. The kind of darkness that exists when there are no stars to break it, no galaxies to punctuate it, nothing but the smooth, featureless expanse of cooling hydrogen gas spread thin across space, waiting. Let us sit with that darkness for a moment. Close your eyes if they are not already closed. Imagine a universe without a single point of light. No sun, no stars, no distant galaxies glowing on the horizon. Just darkness, stretching in every direction, forever. This was the universe for hundreds of millions of years after the Big Bang. Astronomers call it the cosmic dark ages, and it is one of the most fascinating and least understood periods in cosmic history. It began about 380,000 years after the Big Bang, the moment when the universe cooled enough for atoms to form and light to travel freely. That is the moment we see when we observe the cosmic microwave background, that faint glow coming from every direction in space. But after that moment, after that first release of light, the universe went dark, because there was nothing left to shine. The early universe was just hydrogen and helium, simple atoms scattered through expanding space, cooling as they spread. There were no stars yet. Stars require gravity to pull gas together, to compress it until it is hot enough and dense enough for nuclear fusion to ignite. And that process takes time. Lots of time. The gas had to cool, had to settle into clumps, had to be pulled together by the subtle variations in density left over from the Big Bang. It was a slow process, this gathering, this gradual collapse of matter into the first structures. And so the universe waited, in darkness. Imagine it. Hundreds of millions of years passing in total night. No light to mark the passage of time, no stars to wheel across a sky, no planets orbiting suns. Just the slow, patient motion of gravity, pulling hydrogen into denser and denser regions, building the scaffolding on which the first stars would eventually form. It is hard to picture, isn't it? Hard to wrap our minds around a universe so empty, so dark, so quiet. But that darkness was not nothing. It was potential. Every atom drifting through space, every slight overdensity in the primordial gas, every tiny fluctuation left over from the Big Bang, all of it was preparation. The universe was not dead during the Dark Ages. It was germinating, like seeds buried in soil, invisible and still, waiting for the right conditions to sprout. And then, slowly, the first stars began to form. We do not know exactly when this happened. The earliest stars are too distant, too faint, and too obscured by the passage of time for us to observe directly. But we think it was somewhere between 100 million and 200 million years after the Big Bang. In cosmic terms, that is early. In human terms, it is an eternity. But whenever it was, whenever that first star ignited, it changed everything. These first stars were different from the stars we see today. They were massive, hundreds of times the mass of the sun, burning incredibly hot and bright. They had to be massive because they were made from pure hydrogen and helium, with none of the heavier elements that help later stars form more easily. And because they were so massive, they burned fast. Their lives were brief, violent, spectacular. A few million years, maybe less, and then they exploded as supernova, seeding the universe with the first heavy elements, carbon, oxygen, iron, all the building blocks that would eventually make planets and life possible. But for that brief time, while they burned, they were the only light in the universe. Imagine standing in a vast, dark field and seeing, far in the distance, a single candle flicker to life. That is what the first stars were like. Points of light in an ocean of darkness, small and scattered and impossibly far apart, but burning nonetheless. And then there were more. The explosions of those first stars triggered new waves of star formation. The heavy elements they produced allowed smaller, longer-lived stars to form. Gravity continued its patient work, pulling gas into galaxies, into clusters, into the large-scale structure we see today. Slowly, the darkness began to fill with light. This was not a sudden transformation. It took hundreds of millions of years for the universe to go from mostly dark to mostly lit. But it was happening. The cosmic dark ages were ending. The age of stars was beginning. And here's the beautiful part. The darkness we are describing, this long night after the Big Bang, was the darkest the universe has ever been or ever will be. During the Big Bang itself, the universe was filled with light, even if that light could not travel far through the opaque plasma. And ever since the first stars formed, there has always been some light, somewhere, breaking the darkness. But during the Dark Ages, there was nothing, just the faint glow of the cosmic microwave background, already stretched into invisibility, and the cold hydrogen waiting to become something more. The universe has never been that dark again, and it never will be, because even in the far future, when star formation has ceased and the last stars have died, there will still be remnants. Black holes, neutron stars, white dwarfs cooling into black dwarfs. Faint, perhaps, invisible to the eye, but not the absolute, total darkness of the Dark Ages, when nothing had yet formed, when the universe was still learning what it could become. So when we think about the brightest moment of the universe, it helps to know where we started. We started in darkness. Not the darkness of endings, but the darkness of beginnings. The darkness of potential, of waiting, of seeds buried deep. And from that darkness, slowly, patiently, the universe learned to shine. Take a slow breath. Let that image settle. The Dark Ages were not a failure or a void. They were necessary. They were the time when gravity did its slow work, when matter gathered, when the stage was set for everything that would follow. You cannot have light without darkness to break through. You cannot have stars without the long, patient wait for gravity to pull hydrogen into the first burning cores. The darkness mattered. It was part of the story, and appreciating it, sitting with it, understanding what the universe was like before stars, that makes the brightness to come all the more remarkable. Because the light did come, the first stars ignited, galaxies began to form, and the universe, once dark and featureless, began to fill with structure, with color, with the soft glow of distant suns. The cosmic Dark Ages ended not with a sudden flash, but with a slow, steady dawn, stretching across hundreds of millions of years, spreading light across space one star at a time. And that dawn is still, in a sense, happening. Every new star that forms is part of that long awakening, that gradual illumination of the cosmos. The universe learned to shine billions of years ago, but it is still shining now, still carrying forward the light that began when the first star broke through the darkness and changed everything. We live downstream from that moment. Every photon of starlight that reaches us, every galaxy we see through our telescopes, every glimmer of the Milky Way stretched across the night sky, all of it traces back to that first flicker, that first candle lit in the dark. And it makes you wonder, doesn't it? If the universe was dark for so long, and if it will be dark again someday, what does it mean that we are here now in the time of light? What does it mean that we exist in the brief window between the darkness that was and the darkness that will be, when the universe is full of stars and galaxies and the soft, steady glow of a cosmos that learned to shine? It means we are witnessing something temporary, something precious, something that had a beginning and will have an end. The light is not eternal. The stars will not burn forever. But right now, in this moment, they are burning. The universe is bright, and we are here to see it. Let that settle. Let yourself feel the weight of it, the impermanence of it, the strange and beautiful fact that light itself is something the universe had to learn, something it created out of darkness, something it will eventually let go. But that is for later. For now, the stars are shining. The cosmic Dark Ages are long over, and we are about to enter the next chapter of the story, the chapter where the universe reaches its peak, where star formation explodes across space, where galaxies blaze with the fever of creation. The brightness is coming, and it is going to be extraordinary. The universe learned to shine, and then, about 10 to 11 billion years ago, it learned to shine brilliantly. This era has a name in cosmology. It is called cosmic noon, and the name is perfect, isn't it? Noon, the moment when the sun is highest in the sky, when light pours down from directly overhead, when shadows are shortest and the world is at its brightest. Cosmic noon was like that. Not a single instant, but an epoch, a window of time perhaps 1 billion years wide, when the universe reached its peak of activity, when star formation blazed across space at rates we can barely imagine, when galaxies collided and merged and burst with newborn suns like nothing we see today. If we are asking whether we live near the brightest moment of the universe, we have to understand cosmic noon, because in many ways, that was the brightest moment. That was when the universe was at its most productive, its most fertile, its most alive with the fever of creation. And we have already passed it. Cosmic noon ended about 3 to 4 billion years ago. We are living in what you might call cosmic afternoon, when the light is still strong but no longer at its peak, when the heat of the day has started to fade and the long descent toward evening has begun. But let us go back. Let us stand at cosmic noon and see what it was like. Imagine the universe 10 billion years ago. Galaxies were younger then, smaller, less organized. They were still forming, still gathering mass through collisions and mergers. Gas was abundant, streaming into galaxies along vast cosmic filaments, feeding the fires of star formation. And those fires were intense. Galaxies at cosmic noon were forming stars at rates 10 times, 20 times, 30 times faster than galaxies today. Some were producing hundreds or even thousands of solar masses worth of stars every year. To put that in perspective, the Milky Way, our home galaxy, currently forms about 1 or 2 new stars per year. That is a slow, steady trickle of birth, enough to keep the galaxy alive, but nothing dramatic. But at cosmic noon, galaxies like the Milky Way were forming 10 or 20 stars per year. And the most active galaxies, the ones caught in collisions or fed by massive inflows of gas, were forming hundreds. Stars were being born in dense clusters, in sprawling nebulae, in chaotic regions where gas and dust collided and compressed and ignited into nuclear fusion. The universe was loud with star formation. If you could hear across space, you would hear the roar of supernova, the hiss of stellar winds, the crack of gas clouds collapsing under their own gravity. It was a time of violence and creation, of destruction and renewal, of constant, relentless activity. And it was not just star formation. Black holes at the centers of galaxies were feeding too, growing fat on the same gas that fed the stars, glowing as quasars and active galactic nuclei, blazing so brightly that they outshone entire galaxies. The universe at cosmic noon was a riot of energy, of light, of motion. It was the peak of cosmic productivity, the moment when the universe was doing the most work, building the most stars, releasing the most energy into space. Most of the stars in the Milky Way were born during cosmic noon. Most of the stars you see in the night sky, if you could trace their history back far enough, would lead you to this era. The universe was building the structures we see today, forging the galaxies, the clusters, the superclusters, all of it happening at a pace that would slow, gradually, inevitably, as the gas supplies ran low and the collisions became less frequent and the universe settled into a quieter, more mature state. But at cosmic noon, the building was still in full swing. The construction site was at its busiest, and the light from all that activity, from all those stars being born, from all those black holes feeding, from all those galaxies colliding, that light was pouring into space in quantities that have never been matched since. So in one sense, cosmic noon was the brightest moment. It was the moment when the universe was emitting the most light, when the most energy was being released, when the most stars were being forged. If you could measure brightness by the rate of star formation, cosmic noon would be the clear winner. Nothing before it or after it comes close. But here's where it gets interesting. Brightness can be measured in different ways, and cosmic noon, for all its intensity, was not necessarily the moment when the most stars existed. Because stars take time to accumulate, the stars formed during cosmic noon did not all appear at once. They were spread across hundreds of millions of years, and many of them, especially the massive ones, burned out quickly, exploding as supernova or collapsing into black holes, vanishing from the cosmic census almost as soon as they appeared. The total number of stars alive at any one time depends not just on how fast they are being born, but also on how long they live. And that balance, that equation between birth and death, plays out over billions of years. Cosmic noon was the peak of birth, but it may not have been the peak of population. We will come back to that. For now, let us just appreciate cosmic noon for what it was. A time of extraordinary activity, of incredible brightness, of the universe at its most energetic and productive. If you could travel back in time and observe the universe from cosmic noon, you would see galaxies that look very different from the ones we see today. They would be smaller, more chaotic, less organized. Spiral structures would be less defined. Elliptical galaxies would still be forming through mergers. Gas would be everywhere, streaming into galaxies, glowing in the light of newborn stars, sculpted by supernova and stellar winds into intricate, beautiful shapes. And the night sky, if you could stand on a planet somewhere in the universe at cosmic noon, would be astonishing. Brighter, in a sense, than our sky today. Not because there were more stars overhead, but because the stars being born were, on average, more massive, hotter, bluer, shorter-lived. The light would be different. Harsher, perhaps. More ultraviolet radiation, more supernova, more danger for any fragile life trying to take hold on a planet's surface. But also more spectacular, more vivid, more alive with the raw energy of creation. Cosmic noon was not a gentle time. It was a time of extremes, of high temperatures and intense radiation, of galaxies tearing each other apart and rebuilding themselves from the wreckage. But it was also a time of incredible beauty, of the universe at its most creative, its most dynamic, its most full of potential. And then it ended. Not suddenly, not with a bang, but with a slow decline. The rate of star formation began to drop. Gas supplies started to run low. Collisions between galaxies became less frequent as the expansion of the universe carried them farther apart. The universe began to settle, to mature, to calm down from the frenzy of cosmic noon into something quieter, something more like what we see today. That decline is still happening. Star formation has been decreasing for billions of years, and it will continue to decrease for billions more. The universe is not done making stars, not by a long shot. There are still vast reserves of gas out there, still galaxies forming new suns, still nebulae glowing with the light of stellar birth. But the peak has passed. Cosmic noon is over, and we are living in the long afternoon that follows, when the light is still strong but no longer at its zenith, when the shadows are starting to lengthen and the day, slowly, imperceptibly, is beginning to wane. There is something melancholy about that, isn't there? The idea that the universe's most active moment is behind us, that we missed the peak, that we are living in the decline rather than the ascent. But there is also something comforting about it. Because decline, in this case, is not collapse. It is maturation. The universe at cosmic noon was young, chaotic, violent. The universe today is older, calmer, more structured. Stars form more slowly, but they also live longer, burn more steadily, create more stable environments for planets, and, potentially, for life. Cosmic noon was the peak of star formation, but it may not have been the peak of everything. And that's worth exploring, because if we are asking whether we live near the brightest moment, we need to think carefully about what brightest means. Is it the moment when the most stars are being born? Or is it the moment when the most stars exist? Is it the moment of maximum energy or the moment of maximum accumulation? These are different questions, and they have different answers. Let that thought rest for a moment. Cosmic noon was extraordinary. The peak of star formation, the zenith of cosmic productivity, a time when the universe blazed with the fever of creation. But it was also chaotic, violent, unstable. The stars being born then were often massive and short-lived. The galaxies were turbulent and disorganized. And the total number of stars, the accumulated light of all those billions of years of birth, may not have reached its maximum yet. Because stars take time to add up. And the long-lived stars, the small red dwarfs that burn for trillions of years, those stars have been accumulating ever since cosmic noon. Every new star that forms adds to the total. And even though the rate of formation is slower now, the total number, the cosmic census of stars currently shining, may still be climbing. Or it may have just peaked. Or it may peak very soon. We are close, very close, to the moment when the most stars exist at once, when the night sky, if you could see all of it from everywhere, would be at its fullest, its most populated, its most bright, not with the intensity of star formation, but with the sheer abundance of stars still burning. And that's where we are going next, to the present, to now, to the question of whether this moment, this era we are living in, might be the true peak. Not the brightest in terms of birth rate, but the brightest in terms of total light. The most stars ever alive at once. The fullest the universe will ever be. Take a slow breath. We have traveled from the darkness of the cosmic dark ages through the blazing intensity of cosmic noon. Now we are arriving at the present, at the moment you are living in, the stars you see, the universe as it is right now. And we are going to ask, gently, carefully, whether this might be the brightest moment of all. The answer might surprise you, and it might change how you feel about the night sky, about the stars above you, about the fleeting, precious era of light you happen to inhabit. But we will take our time. We will let the question unfold slowly, the way the universe itself unfolds, patient and gradual and full of quiet revelation. The peak may be now, and if it is, that makes this moment, your moment, something extraordinary. So here we are, the present, this moment, the universe as it exists right now, 13.8 billion years after the Big Bang, 3 to 4 billion years after cosmic noon, countless trillions of years before the last star will die. Where do we stand? Are we living in the aftermath of brightness, watching the slow fade of a universe past its peak? Or is there something else happening, something less obvious, but no less profound? The answer depends on how you measure brightness. And this is where the story becomes not just interesting, but deeply personal. Because the measure that matters, the one that might place us at the very peak of cosmic luminosity, is not about how fast stars are being born. It is about how many stars exist right now, at this moment, burning across the universe. Let us slow down and think about this carefully. Cosmic noon, that era 10 to 11 billion years ago, was the peak of star formation. Galaxies were forging stars at rates we will never see again. But star formation rate is not the same as total stellar population. It is the difference between birth rate and total population. A city might have had a baby boom 50 years ago, but if those babies grew up and stayed in the city, and if people keep being born even at a slower rate, the total population might still be climbing. It might reach its maximum not during the boom, but decades later, when all those generations accumulate. The universe works the same way. Stars have been forming for over 13 billion years. And while the rate of formation peaked at cosmic noon, the stars themselves, especially the small, long-lived ones, have been accumulating ever since. Red dwarfs, those faint stars with a fraction of the sun's mass, can burn for 10 trillion years or more. Every red dwarf that formed at cosmic noon is still shining today. Every red dwarf that formed a billion years ago is still shining. Every red dwarf being born right now will still be shining trillions of years from now. long after every massive star has exploded, long after the sun itself has swelled into a red giant and faded into a white dwarf. This accumulation matters, because even though star formation is slower now than it was at cosmic noon, the universe has had billions of years to build up its stellar population. And that population, that total census of stars currently burning, might be at or very near its maximum right now. Think about it this way. Imagine a slowly filling bathtub. Early on, you turn the faucet on full blast. Water pours in fast, the level rises quickly. That's cosmic noon. Then you turn the faucet down. The water still flows, but slower. The level keeps rising, but more gradually. At some point, the bathtub reaches its fullest. Not when the faucet was on full blast, but later, when all that water has accumulated. That fullest point might be now, or it might be very, very soon. Current estimates suggest there are about 10 to the power of 24 stars in the observable universe. That's a 1 followed by 24 zeros. A septillion stars. More stars than grains of sand on all the beaches on Earth. More stars than seconds have passed since the Big Bang. It is a number so large it defies comprehension, and yet it is precise enough that astronomers can calculate it, estimate it, track how it changes over time. And that number, that total population, might represent the peak. Not because star formation has suddenly increased, but because 13 billion years of slow, steady birth has finally caught up with and surpassed the losses from stars dying. The balance may have tipped. We may be living at the moment when the most stars exist simultaneously. Of course, we cannot know this with absolute certainty. The universe is vast, and our observations are limited. We can see only the observable universe, a sphere of space about 93 billion light-years across. Beyond that, there's more universe, probably much more, but it is hidden from us by the expansion of space and the finite speed of light. So when we talk about the total number of stars, we are really talking about the observable total, the stars we could, in principle, detect if we had powerful enough telescopes and infinite time. But even with that caveat, the evidence points to a remarkable conclusion. We are close to the peak, maybe at it, maybe just past it, maybe with a few 100 million years still to go before the maximum. In cosmic terms, that's a rounding error. We are near enough to the brightest moment that we might as well call it the present. And what does that mean? What does it feel like to live at the peak of stellar population? It means the night sky you see, or imagine seeing, is as full as it will ever be. It means if you could somehow step outside the Milky Way and look at the universe from a cosmic vantage point, you would see more galaxies, more stars, more light than at any other moment in the past or future. It means the universe has never been brighter in this particular sense and will never be brighter again. The lights are on, all of them. The stage is full. The cast has assembled, and we are here, watching, living, breathing under this sky, in this moment when the cosmos is at its most luminous. There is something both humbling and uplifting about this realization, isn't there? Humbling because it reminds us how contingent our existence is, how much we depend on timing, on being born at the right moment in cosmic history. Uplifting because it means we are not living in the ruins of a brighter past. We are living in the brightness itself, the peak, the maximum, the fullest the universe will ever be. And yet, the decline has already begun. Even if we are at the peak of total stellar population, we are past the peak of star formation. Fewer stars are being born each year than in the past. The gas supplies that fuel star formation are being depleted, locked up in stars and planets and brown dwarfs, or heated by supernova and blown out of galaxies into intergalactic space. The universe is running out of raw material. This decline is slow, painfully slow by human standards. It will take billions of years for the effects to become obvious, but it is happening. The rate of star formation is dropping, and it will continue to drop, asymptotically approaching zero over timescales that make the current age of the universe seem brief. In 1,000,000,000,000 years, star formation will be a shadow of what it is now. In 100,000,000,000,000 years, it will have effectively ceased. The last stars will form in isolated pockets of gas, rare and precious, the final embers of a dying fire. And then, for an incomprehensibly long time, the universe will coast on the stars it has already made. Red dwarfs will burn for 10 trillion years, 100 trillion, giving off faint red light in an increasingly dark and empty cosmos. White dwarfs will cool slowly, fading from white to red to black over timescales measured in 10 to the power of 100 years or more. The brightness will fade, not all at once, not in any way we could witness, but inexorably, patiently, the way snow melts in spring or embers cool after a fire burns out. The universe will grow dimmer, and dimmer still, until eventually, in the unimaginably distant future, there will be no stars left at all. Just remnants. Black holes, neutron stars, black dwarfs, all cold and dark, drifting through a space so vast and empty that even these remnants might never encounter each other again. But that's not now. That's not even close to now. Right now, the stars are shining. The universe is bright, and we are here, in the middle of it, witnesses to the peak or something very near it. Take a moment to breathe with that, to feel the weight and the lightness of it. You exist at a special time, not because the universe arranged itself for your benefit, but simply because of when you were born, when your species emerged, when your planet formed and your star ignited and your ancestors looked up at the night sky and began to ask questions about what they saw. You exist at the brightest moment, or close enough that the difference does not matter. And that means the stars you see are not just points of light. They are participants in a story, a cosmic arc that began in darkness, rose to a peak of light, and will eventually return to darkness. You are living in the middle of that arc, at the top, where the light is strongest and the universe is fullest, and the story, if you want to call it that, is at its most dramatic. This is not an accident. Well, it is, in the sense that your birth was random, contingent, the result of countless small chances across billions of years. But it is also not an accident, because here you are, living now, in this moment, when the universe happens to be at its peak. What do you do with that knowledge? How do you hold it? Maybe you do not hold it at all. Maybe you just let it settle, let it color the way you see the night sky, let it add a layer of meaning to the stars above you. They are not eternal. They are temporary, and you are seeing them at their best, their fullest, their brightest. That's a gift. Not a gift anyone gave you, but a gift nonetheless. The gift of timing. The gift of being here when the lights are on. And it makes you wonder, doesn't it? What will future beings, if they exist, think when they look up at a sky with fewer stars, dimmer galaxies, less light? Will they know what they are missing? Will they be able to reconstruct the brightness that once was? Or will it be lost to them, hidden behind the veil of time and the slow extinction of stars? We can know, we can see, we can measure and calculate and understand that we are living near the peak. That's a privilege, a responsibility, even, to notice, to appreciate, to carry the awareness that this moment is special not because it lasts forever, but because it does not. The brightness is temporary, and we are here to witness it. Right now, at the peak, or close enough. Rest with that. Let it bring a kind of peace, a kind of gratitude. The universe is bright. The stars are shining, and you are alive to see them. In the era when they shine most abundantly, when the cosmic stage is fullest, when the light, for a brief and precious window, fills the void. This is the present. This is now. And it might just be the brightest moment of all. We have arrived at the peak, or something very near it. The present moment, when the universe holds more stars than it ever has before, when the night sky is at its fullest, when light floods the cosmos in quantities that will never be matched again. It is a beautiful place to pause, to appreciate, to feel the privilege of being here now. But we cannot stay at the peak forever. Not because we are in a hurry, but because the story does not end here. The The universe continues. Time moves forward. And what comes after the peak is not collapse or darkness all at once, but something quieter, slower, more patient. A dimming. A gradual fade that will stretch across timescales so vast, they make the current age of the universe seem like a brief flicker. Let us walk into that future together. Gently. Not to frighten ourselves with endings, but to understand them. To see the full arc of cosmic brightness from beginning to end. To appreciate that even decline has its own kind of beauty. The future begins simply enough. Star formation continues, but at a slower and slower rate. Galaxies still have gas, still have clouds collapsing into newborn suns, but the fuel is running low. The reserves that fed the frenzy of cosmic noon are largely depleted. What remains is scattered, thin, harder to pull together into dense enough clumps to ignite fusion. In a billion years, the Milky Way will look much the same as it does now. Perhaps a bit quieter, a bit less active, but still recognizable. Stars will still form in its spiral arms. Nebulae will still glow with the light of stellar birth. And the night sky from Earth, if Earth still exists, will still be full of stars. The decline is too slow to notice on such short timescales. But in 10 billion years, the change will be more apparent. Star formation will have dropped significantly. Many of the massive, bright stars we see today will be long gone, exploded as supernova or collapsed into black holes. The galaxy will be dominated by older, redder, longer-lived stars. The night sky will be dimmer, not because stars are disappearing all at once, but because the bright blue giants that light up our current sky will have burned out, leaving only the fainter, cooler stars behind. And the gas, the raw material for new stars, will be even scarcer. Much of it will have been used up, turned into stars and planets. Some of it will have been blown out of galaxies by supernova and stellar winds, heated to such high temperatures that it can no longer cool and collapse. Some will be locked up in brown dwarfs, objects too small to sustain fusion, sitting in the dark like failed stars, waiting. The universe will still be making stars, but fewer and fewer. And the stars it does make will tend to be smaller, redder, longer-lived. Red dwarfs, the faint embers of stellar evolution, will become the dominant form of new star. They burn slowly, efficiently, sipping their hydrogen fuel over trillions of years. They are not spectacular. They do not light up the sky, but they endure. In 1 trillion years, 1,000 billion years from now, star formation will be almost over. The last great waves of stellar birth will have passed, leaving only isolated pockets of gas here and there, rare and precious, forming the final generation of stars. These stars will be born into a universe very different from the one we know. A universe where most galaxies have merged into a few enormous ellipticals, where the expansion of space has carried distant galaxies so far away that they have vanished beyond the cosmic horizon, where the cosmic microwave background has cooled to near absolute zero and the night sky, from most vantage points, is almost empty. The beings who live in that era, if any do, will see a cosmos that looks quiet, cold, and static. They won't see the sprawling web of galaxies we see today. They won't detect the faint glow of the Big Bang. They will have no direct evidence that the universe ever had a beginning or that it is expanding. Their science, if they develop one, will be limited by the poverty of their observations. They will live in a time of darkness, relative to our own, and they may never know what they have missed. But even in 1 trillion years, there will still be stars, red dwarfs, burning faintly, scattered through the merged remnants of galaxies. And those stars will continue to burn for a very long time. 10 trillion years. 100 trillion. Some estimates suggest the smallest red dwarfs could shine for 10 to the power of 14 years, 100 trillion years, before finally exhausting their fuel and fading into white dwarfs. That's an almost incomprehensible span of time. The current universe is less than 14 billion years old, 10 to the power of 10. 100 trillion years is 10,000 times longer. It is a future so distant that trying to imagine it feels like trying to picture infinity. And yet, throughout all that time, there will be stars. Faint, dim, barely visible even if you were standing on a planet orbiting one. But stars nonetheless. Light in the darkness. The last remnants of the cosmic fire that began so long ago. And then, eventually, even those will go out. The last red dwarf will cool and fade, contracting into a white dwarf, a dense ember of carbon and oxygen, no longer producing light through fusion, but glowing faintly from residual heat. And over timescales measured in 10 to the power of 30 or 40 years, those white dwarfs will cool further, fading from white to red to black, becoming black dwarfs, cold and invisible, drifting through space like cosmic tombstones. At that point, star formation will be over. Completely. Forever. The universe will have exhausted its ability to make stars. The gas will be gone, used up or dispersed, and the raw materials will be locked into remnants, white dwarfs, neutron stars, black holes, objects that will never ignite again, never burn, never shine. The universe will be dark. Not the darkness of the cosmic dark ages, when the potential for light still existed, when gravity was still gathering gas into the first stars, but the darkness of endings. The darkness of a cosmos that has run its course, that has burned through its fuel and settled into a final, quiet state. But even that's not the end. Black holes will remain, evaporating slowly through Hawking radiation over timescales of 10 to the power of 100 years. Neutron stars will sit in the dark, spinning slower and slower as they lose energy. Black dwarfs will drift through space, cold and inert. And the universe will continue to expand, carrying these remnants farther and farther apart, until even they are isolated, alone in the vastness, unlikely ever to interact again. This is the far future, the heat death of the universe, the final state, as far as we can predict with current physics. A cold, dark, empty expanse, dotted with invisible remnants, expanding forever, cooling forever, fading into a silence so complete it is almost holy. It is hard not to feel a kind of melancholy when thinking about this future. The idea that all the light, all the beauty, all the complexity we see in the universe today will one day be gone, not destroyed but simply exhausted, used up, faded into nothing. It is the ultimate impermanence, not just the impermanence of individual lives or civilizations or even species, but the impermanence of stars, galaxies, light itself. And yet, there's something strangely peaceful about it too. The universe is not being destroyed. It is completing a cycle. It started in darkness, learned to shine, and will return to darkness. Not because something went wrong, but because that's the nature of things. Fires burn, and then they go out. Light shines, and then it fades. That's not a tragedy. It is just the way the story unfolds. And we are not living in that far future. We are not witnessing the end. We are living now, in the middle, when the stars are still shining, when the universe is still bright, when the decline has begun but hasn't yet progressed far enough to notice in a single human lifetime or even a single epoch of human civilization. The dimming is happening, but it is slow. So slow that we can still look up at the night sky and see it full of light, still watch stars being born, still observe galaxies in all their complexity and beauty. The decline does not erase the present. It just gives it context. It reminds us that what we have is temporary, and that makes it more precious. Take a slow breath. Let the melancholy and the peace exist together. The future dimming is real. The lights will go out, one by one, over incomprehensible stretches of time. But that future is not this moment. This moment is still bright, still full, still alive with the accumulated light of 13 billion years of star formation. You are not living in the aftermath. You are living in the peak, or just past it, in the era when the universe is at its fullest, when the most stars exist, when light still floods space in quantities that will never be equaled again. The decline has begun, yes, but the brightness remains. And it will remain for a long time yet, long enough that every human being who has ever lived or ever will live will see a sky full of stars, will witness the universe in its luminous middle age. That's comforting, isn't it? The dimming is so slow that it does not touch us. We are sheltered from it by the sheer scale of cosmic time. We live in the light, and we will continue to live in the light for as long as our species exists, for as long as any species like us could possibly exist. The far future is dark, but the near future, the future we can imagine and relate to, is still bright. The stars will keep shining, the galaxies will keep glowing, and the night sky will remain a testament to the universe's long, slow arc from darkness through light and back to darkness again. We are in the light, and that's where we will stay, at least for now, at least for as long as now means anything to us. Rest with that. Let it bring comfort. The dimming is real, but it is distant. The brightness is temporary, but it is here, and you are part of it, living in the fullest moment, when the cosmic stage is crowded with stars and the universe, for a fleeting window in its vast history, shines with more light than it ever has or ever will. The future will be dark, but the present is bright, and that's all that matters. That's all we need. We have traveled through time, from the cosmic dark ages through the blazing peak of cosmic noon to the present moment and into the slow dimming of the far future. And along the way, we have used the word brightest many times. But what does it really mean? What are we actually measuring when we ask whether we are living near the brightest moment of the universe? The answer is more nuanced than it might first appear, because brightness is not a single thing. It is not a simple number you can point to and say, there, that's the peak. Brightness has layers, dimensions, different ways of being measured, each one telling a slightly different story about when the universe shines most intensely. Let us sit with this for a moment and explore the different meanings of cosmic brightness. The first and most obvious measure is total luminosity. This is the raw amount of light being emitted by the universe at any given moment. How many photons are pouring into space from stars, galaxies, quasars, all the luminous objects scattered across the cosmos? If you could somehow add up all that light, all those watts of energy being radiated, you would get a number. And that number changes over time. At cosmic noon, total luminosity was probably at or near its peak. Star formation was at its highest rate, and stars, especially the massive, bright ones, were being forged in huge numbers. These massive stars burn hot and bright, pouring out enormous amounts of energy in their brief lives. So even though they do not live long, while they are burning, they contribute disproportionately to the universe's total light output. By this measure, we are past the peak. Cosmic noon was the brightest era in terms of raw energy output. The universe is dimmer now than it was then, and it will continue to get dimmer as star formation slows. And the massive, bright stars die off without being replaced at the same rate. But total luminosity is only one way to measure brightness. Another way, the one we have been focusing on, is total stellar population. How many stars exist right now, regardless of how bright they are? This measure cares less about energy output and more about number. And by this measure, as we have explored, the peak might be now or very close to now. Because even though star formation has slowed, stars have been accumulating for billions of years, and the long-lived red dwarfs are still adding up. Then there's star formation rate itself. This is the measure of how many stars are being born per unit time, usually expressed in solar masses per year per cubic megaparsec. It is a measure of activity, of cosmic productivity, of how busy the universe is at making new stars. And by this measure, the peak was definitely at cosmic noon. Star formation has been declining ever since, and while new stars are still being born, the rate is much, much lower than it was billions of years ago. Another measure is galaxy activity. How many quasars are blazing? How many active galactic nuclei, are feeding and glowing. How many galaxies are colliding and triggering starbursts? This kind of activity was also highest around cosmic noon, when galaxies were younger, more gas-rich, more prone to mergers. Today's universe is calmer, more mature. Most galaxies are settled into stable forms, their central black holes quiet, their gas supplies diminished. By this measure, too, we are past the peak. But there's another dimension to brightness that's less about physics and more about potential. The potential for life. The potential for planets in habitable zones around stable stars. The potential for complexity, for consciousness, for beings who can look up at the sky and ask questions about what they see. At cosmic noon, despite all its brilliance, the universe was a dangerous place. High rates of supernova, intense radiation, frequent galaxy collisions, all of it created environments hostile to the kind of stable, long-term evolution that complex life seems to require. Planets were being formed, yes, but they were being bombarded, irradiated, disrupted. Life, if it existed, would have had a hard time taking hold. Today's universe is calmer. Stars burn more steadily. Supernovae are rarer. Galaxies are more stable. And the stars being formed now, and the stars that formed in the last few billion years, are often sun-like or smaller, capable of supporting planetary systems for billions of years without dramatic disruptions. By the measure of habitability, of potential for life, we might be at or near the peak right now. This is a different kind of brightness. Not the brightness of raw energy, but the brightness of possibility. The glow of a universe that has matured enough to be stable, but hasn't yet dimmed so much that opportunities are closing. It is the brightness of a cosmos at its most hospitable, its most conducive to the emergence of complexity. And then there's the brightness of knowledge, of visibility, of being able to see and understand the universe's history. We live in an era when the cosmic microwave background is still detectable, when distant galaxies are still visible, when the expansion of space can still be measured. We can see cosmic noon by looking at distant galaxies. We can see the Big Bang by detecting its afterglow. We can reconstruct the entire history of the universe from the evidence written in light. Future observers, trillions of years from now, won't have this privilege. The cosmic microwave background will have cooled beyond detection. Distant galaxies will have been carried beyond the horizon by expansion. The evidence of the universe's history will have faded, leaving future scientists with far less to work with. By the measure of observability, of the universe's willingness to reveal itself, we are living in a peak era. The brightest moment in terms of knowledge. So what does brightest really mean? It depends. It depends on what you are measuring, what you value, what you care about. If you care about raw energy, the peak was at cosmic noon. If you care about total population, the peak might be now. If you care about habitability, we are in a golden age. If you care about knowledge, we are living in a rare window of transparency and evidence. There's no single answer. No moment you can point to and say, unequivocally, that was the brightest. Instead, there's a range of brightness, an era stretching across billions of years, when different measures peak at different times, but all cluster around the same general period. The universe's middle age. Its fullest, richest, most complex period. And we are in it. Not at every peak, not at the maximum of every measure, but near enough to all of them that we can reasonably say this is the brightest era. This is when the universe shines most abundantly, in the ways that matter most to beings like us. Take a breath. Let that complexity settle. The brightness is not a single point, but a window, an era, a golden hour that stretches across cosmic time. And you are in that window. You are living in the richest, fullest, most luminous age the universe will experience. Not because any one measure is at its absolute peak, but because so many of them are close, so many forms of brightness overlap and converge, creating a moment in cosmic history that will never be repeated. This is the brightest moment, not in every way, but in enough ways that it matters. And that makes now, this present, this era you inhabit, something extraordinary. It also raises a question, one worth sitting with before we move on. Why does the universe have a brightest moment at all? Why isn't brightness constant, eternal, unchanging? Why does it rise and fall, peak and decline, follow an arc like a story rather than stretching on forever in the same state? The answer has to do with the nature of stars, of galaxies, of the universe itself. Stars are not eternal. They are fires, and fires burn through their fuel. Galaxies are not infinite reservoirs. They use up their gas, exhaust their supplies, settle into quieter states. The universe expands, spreads matter thinner, makes star formation harder over time. All of these processes conspire to create a peak, a moment when conditions are just right for maximum brightness, followed by a slow decline as those conditions fade. And there's something profound in that. The universe is not a static stage. It is a process, a journey, a story with a beginning, a middle, and an end. The brightness has a lifespan. It is born in the cosmic dark ages, grows through billions of years, peaks somewhere around now, and will slowly fade over trillions of years to come. It is temporary, and that's what makes it beautiful. Permanent brightness would be less remarkable. If the stars burned forever, if galaxies never ran out of gas, if the universe remained bright for eternity, we might take it for granted. We might not notice it. But the brightness is fleeting. It has edges, boundaries, a shape defined by time. And that shape, that arc from darkness through light and back to darkness, is what gives the brightness meaning. We are living in the peak of that arc, the fullest moment, the time when the universe, by many measures, shines most brightly. And knowing that, feeling that, holding that awareness as you look up at the night sky, changes everything. The stars are not eternal. The brightness is not guaranteed. And that makes this moment, your moment, a gift. The gift of being here when the lights are on, when the stage is full, when the universe is at its most radiant. Rest with that. Let it bring a sense of gratitude, of presence, of being exactly where you need to be in cosmic time. The brightest moment is not a single instant. It is an era, and you are in it. That's what brightest really means. It means now. It means this. It means the convergence of many kinds of light, many forms of brightness, all peaking or near peaking together, creating a window in cosmic history when the universe is at its fullest, its most alive, its most rich with stars and possibility and the soft glow of accumulated light. You are living in the brightest moment, and that's extraordinary. So we are living near the brightest moment, perhaps at it, perhaps just past it, perhaps with a few 100 million years still to climb before the final peak. In cosmic terms, the difference does not matter. We are close enough that we can call this era, this present, the time of maximum brightness. But there's another layer to this story, another reason why our moment in cosmic history is so remarkable. It is not just that the universe is bright now. It is that we can see that brightness. We can measure it. We can understand it. We can look out into space and time and witness the full arc of cosmic evolution, from the Big Bang to the present, and even glimpse what's to come. This ability, this privilege of observation and knowledge, is itself temporary. It is a window within a window, a brief era when the universe is not only at its brightest, but also at its most transparent, its most willing to reveal its secrets. And we happen to live in that overlap, that convergence of brightness and visibility, making our moment doubly special. Let us explore what this means. When we look out into space, we are also looking back in time. Light takes time to travel, so the further away something is, the older the light we are seeing. A star 10 light years away shows us how it looked 10 years ago. A galaxy a billion light years away shows us how it looked a billion years ago. And the cosmic microwave background, the faint glow coming from every direction, shows us the universe as it was 380,000 years after the Big Bang, when it first became transparent. This means we can see cosmic noon. not as it is now, but as it was, frozen in the light that left those distant galaxies billions of years ago. When we point our telescopes at the deep sky and detect faint, red-shifted galaxies, we are witnessing the peak of star formation, the era of maximum activity, the time when the universe was forging stars at rates that will never be matched again. We can see it directly, watch it unfold, study it in detail. This is extraordinary. We are living billions of years after cosmic noon, but we can still observe it because light from that era is still reaching us. It is like being able to watch history unfold in real time, not through records or artifacts, but through the actual light emitted by events as they happened. The universe has given us a time machine, and it is called the speed of light. But this time machine only works now. In the far future, when the universe has expanded much more, when distant galaxies have been carried beyond the cosmic horizon by the accelerating expansion of space, future observers won't be able to see cosmic noon. They won't be able to detect the cosmic microwave background. They won't have direct evidence of the Big Bang or the early universe. The light from those events, stretched and reddened by billions more years of expansion, will have faded beyond detection, or will have been carried so far away that it can never reach them. Those future observers will live in a much darker cosmos, not just because star formation will have slowed, but because their view of the universe will be limited. They will see only their local cluster of galaxies, the ones bound together by gravity and immune to the expansion. Everything else will have vanished beyond the horizon, and with it, the evidence of cosmic history will have vanished too. They will have to take much more on faith. They won't be able to measure the expansion of the universe because there won't be distant galaxies to measure. They won't be able to detect the cosmic microwave background because it will have cooled beyond their instruments' reach. They won't be able to see cosmic noon because those galaxies will be long gone from view. Their science will be impoverished, limited by the poverty of their observations. We, on the other hand, live in an age of abundance. We can see cosmic noon. We can detect the cosmic microwave background. We can measure the expansion. We can observe galaxies at every stage of their evolution, from the earliest formations just a few 100 million years after the Big Bang to the mature spirals and ellipticals we see nearby. We can reconstruct the entire history of the universe from the evidence written in light. This is a privilege, not a privilege someone granted us, but a privilege of timing, of being born at the right moment in cosmic history when the universe is still young enough that its history is visible, still transparent enough that light from the distant past can reach us. And it is not just about seeing the past. It is also about seeing the present in its fullness. We can observe billions of galaxies scattered across space. We can study the cosmic web, the large-scale structure of filaments and voids that shapes the distribution of matter. We can watch stars being born, see nebulae glowing with the light of new suns, detect planets orbiting distant stars. The universe is still active, still dynamic, still full of processes we can observe and study. Future observers won't have this either. In a universe where star formation has nearly ceased, where galaxies have merged into a few isolated remnants, where the night sky is almost empty, there will be far less to see. Far fewer processes unfolding, far fewer events to witness. The universe will be quieter, calmer, less interesting from an observational standpoint. We are living in the interesting era, the active era, the era when the universe is at its most complex, its most dynamic, its most full of things to observe and study and marvel at. And we are taking advantage of it. As a species, we have built telescopes, satellites, observatories. We have developed the mathematics and the physics to interpret what we see. We have pieced together the story of the universe from scattered photons and faint signals, constructing a coherent narrative that stretches from the Big Bang to the present and beyond. We have become, in a very real sense, the universe's way of knowing itself. That's profound. The universe existed for billions of years without anyone to observe it, to understand it, to ask questions about it. And then, at this particular moment in cosmic history, consciousness emerged. Eyes opened, minds formed. And now, in this narrow window when the universe is both bright and visible, there are beings, us, capable of witnessing it, studying it, appreciating it. We are the eyes of the cosmos, the witnesses, the observers who happen to be here when there's still something to see, when the evidence of cosmic history is still available, when the brightness is still strong enough to be noticed. This makes our moment not just bright, but meaningful. Because brightness without a witness is just physics. Light pouring into empty space, unobserved, unappreciated, meaningless in any subjective sense. But brightness with a witness becomes something more. It becomes beauty, wonder, inspiration. It becomes the raw material for questions, for curiosity, for the drive to understand. And we are the witnesses, right now, in this era, looking up at a sky that will never be fuller, at a universe that will never reveal more of itself, at a cosmic story that will never be more accessible than it is right now. Take a moment to breathe with that, to feel the weight of it. You are living in a privileged moment, not because you are special, not because the universe arranged itself for you, but because of timing. Because you were born into a species that emerged at exactly the right time to see the universe at its brightest and most transparent. A few billion years earlier, and we would be living in a more chaotic, dangerous cosmos. A few billion years later, and we would be living in a dimmer, emptier one. But now, in this Middle Age, we have the best of both. Brightness and stability, activity and visibility, complexity and knowledge. This is the golden hour of the universe, not just the brightest moment, but the most knowable moment, the time when the cosmos is at its most willing to reveal itself. And there's a responsibility that comes with that, isn't there? If we are the witnesses, if we are living in the era when the universe can still be seen and understood, then perhaps we have a duty to look, to study, to appreciate. Not a moral duty, not something imposed from outside, but a natural response to the privilege we have been given. The universe is showing us its history, its structure, its beauty. The least we can do is pay attention. And we are. Collectively, as a species, we are building better telescopes, developing better theories, asking deeper questions. We are mapping the cosmic microwave background, detecting gravitational waves, discovering exoplanets, tracing the large-scale structure of the universe. We are using the time we have, the visibility we have been granted, to learn as much as we can before the window closes. Because it will close. Not for us, not in any timescale that affects humanity, but eventually. The universe will expand further, carry galaxies beyond the horizon, fade the cosmic microwave background into undetectability. The window of maximum visibility will end, just as the window of maximum brightness will end. Both are temporary. Both are gifts of timing. But for now, both windows are open. The universe is bright, and we can see it. We can know it. We can witness the full sweep of cosmic history from our small vantage point on a rocky planet orbiting an ordinary star in a typical galaxy. That's extraordinary. That's the privilege of our moment. Not just to exist during the brightest era, but to exist during the era when that brightness is visible, knowable, accessible to minds willing to ask questions and eyes willing to look. So when you look up at the night sky, remember this. You are not just seeing stars. You are seeing the universe at its peak, in the era when it holds more light than it ever has or ever will. And you are seeing it at a time when it is still possible to see, when the evidence of cosmic history is still available, when the full story can still be told. You are living in the overlap of brightness and visibility. The golden hour. The moment when the universe is both at its fullest and at its most transparent. That's a gift, a cosmic gift, not given by anyone, but present nonetheless. The gift of being here, now, when the lights are on and the view is clear and the story can still be read in the glow of ancient light. Rest with that. Let it bring gratitude. Let it bring a sense of presence, of being exactly where you need to be in time. The privilege of our moment is not just about seeing brightness. It is about knowing it, understanding it, being able to trace the arc from darkness through light and back to darkness, being able to see where we are in that arc and appreciate the fleeting, precious nature of the peak. We are witnesses to the brightest moment, and that makes us, in a small but meaningful way, participants in the universe's attempt to know itself. That's the privilege. That's the gift. And it is yours, right now, simply by being alive in this era, in this window, when the cosmic stage is full and the lights are still on and the story is still being told. We have been walking through cosmic time, from darkness to light and toward darkness again. And along the way, we have used words like brightness, luminosity, peak, abundance. But there's another word that's been present all along, even if unspoken. Beauty. The universe is beautiful. The night sky scattered with stars, the soft glow of nebulae, the spiral arms of galaxies stretching across space. All of it evokes something we call beauty. But beauty, like brightness, is not eternal. It is not a permanent feature of the cosmos. It is something that emerged, flourished, and will eventually fade. Beauty, in the universe, is a temporary condition. Let us sit with that idea for a moment. Let it unfold slowly. Because it is strange, isn't it? We are used to thinking of beauty as something timeless, something that exists in the realm of ideals, unchanging and eternal. A beautiful equation, a beautiful piece of music, a beautiful work of art, they endure. But cosmic beauty is different. It is tied to physical processes that have beginnings and endings. It is contingent on stars forming, on galaxies organizing, on light filling space. And all of these things are temporary. The universe was not always beautiful. In the cosmic dark ages, before the first stars formed, there was no light to create the visual richness we associate with beauty. There were no stars to wheel across a sky, no galaxies to stretch across the void, no nebulae glowing with the soft colors of ionized gas. There was only darkness, featureless and smooth, punctuated by nothing. You could argue that there was a kind of beauty in that simplicity, in the pure potential of a universe waiting to become. But it is not the kind of beauty we mean when we look at images from the Hubble telescope or stand under the Milky Way on a clear night. That beauty requires structure, complexity, light. And none of those existed during the Dark Ages. Beauty had to emerge. It had to be built from the raw materials of hydrogen and helium, from the slow work of gravity pulling matter together, from the ignition of the first stars and the formation of the first galaxies. Beauty in the universe is not a given. It is a product of evolution, of processes unfolding across billions of years. And it will not last forever. In the far future, when star formation has ceased and the last stars have died, when the universe is filled only with cold remnants drifting through the dark, there will be no more visual beauty of the kind we know. No more glowing nebulae, no more spiral galaxies, no more star clusters shining against the void. Just darkness, punctuated by invisible black holes and cooling white dwarfs, objects that emit no light, objects that would be undetectable to the eye even if you were standing next to them. The universe will still exist. It will still have structure, still follow physical laws, still evolve in its slow, patient way. But it will not be beautiful in the sense we mean when we talk about the beauty of the night sky. That beauty, like the brightness, is temporary. It exists in a window, a middle age, when the cosmos is complex enough to be interesting but not so old that everything has faded into darkness. And we are in that window. We are living in the beautiful middle, when the universe is at its most visually rich, its most full of structure and light and color. The galaxies spiraling through space, the nebulae glowing red and blue and green, the star clusters scattered like jewels against the void, all of it exists now, in this era, and will not exist in the same way in the far future. This raises a question. If beauty is temporary, does that make it less real, less meaningful, or does it make it more so? There's a philosophy that finds beauty in impermanence. The Japanese concept of mono no aware, for instance, is about the gentle sadness of things passing. The awareness that beauty is fleeting and that its very transience makes it more poignant, more worthy of attention. Cherry blossoms are beautiful not despite their brief bloom, but because of it. If they lasted forever, they might become ordinary, unnoticed. But because they appear for only a few weeks each spring, people gather to witness them, to appreciate them, to mark their passing. The universe is like that. Its beauty is temporary, and that makes it precious. The stars will not shine forever. The galaxies will not spiral forever. The nebulae will not glow forever. All of it is passing, evolving, fading. And that passing, that evolution, that slow fade, is part of what makes it beautiful. To witness the universe in its beautiful moment is to witness something rare. Not rare in the sense that it happens infrequently, though it does, but rare in the sense that it does not last. It is a fleeting arrangement of matter and energy, a brief flourish of complexity and light in an otherwise simple and dark cosmos. And we are here to see it, not by choice, not by design, but by chance, by the accident of being born at the right moment, in the right place, in the right kind of universe. And that accident, that coincidence, makes the beauty feel like a gift. Think about Earth for a moment. The planet itself is temporary. It formed about 4.5 billion years ago, and it will be destroyed in about 5 billion years when the sun swells into a red giant and engulfs it. The oceans, the continents, the atmosphere, the life, all of it exists in a window, a brief span of time when conditions were just right for complexity to emerge. And within that window, smaller windows. The age of dinosaurs, the ice ages, the brief period of human civilization. Each one temporary, each one a fleeting arrangement of matter that will pass and be replaced by something else. Beauty on Earth is like beauty in the universe. It is tied to processes that have beginnings and endings. It emerges, flourishes, and fades. And yet we do not see that as a flaw. We do not mourn the fact that a sunset only lasts a few minutes, or that spring flowers bloom for only a few weeks, or that a human life spans only a few decades. We see those things as beautiful precisely because they are temporary. The sunset is beautiful because it changes, because it moves through phases of light and color before giving way to night. The flowers are beautiful because they appear, bloom, and fade, marking the passage of seasons. A human life is beautiful, or can be, because it is finite, because each moment is unrepeatable, because time moves in one direction and what is past cannot be revisited. The universe works the same way. Its beauty is tied to its impermanence. The stars are beautiful because they won't last forever. The galaxies are beautiful because they are evolving, changing, moving through phases of their own cosmic life cycle. The brightness of the universe is beautiful because it is temporary, because it had a beginning and will have an end, because we are lucky enough to witness it in its peak. And there's something profound in that. If the universe were static, unchanging, eternal, it might be less interesting. There would be no story, no arc, no sense of journey or evolution. But because the universe changes, because it moves through phases, because it has a history and a future, it becomes something we can relate to. It becomes a story. And stories, by their nature, have beginnings, middles, and ends. We are in the middle, the brightest chapter, the most beautiful moment, not because it is perfect or complete, but because it is full, rich, alive with complexity and light. And knowing that it won't last forever does not diminish it. It enhances it. It makes us pay attention, makes us appreciate what we have while we have it. This is true on a personal level too. You are living a temporary life in a temporary moment of cosmic history. Your days are numbered, as are the days of the stars, as are the days of the universe's brightness. Nothing lasts, and that's okay. That's not a tragedy. It is just the nature of things. Impermanence is not a flaw to be fixed or a problem to be solved. It is a feature of reality, a condition of existence. And within that impermanence, there's beauty. The beauty of change, of evolution, of moments that come and go and cannot be held forever. The universe is teaching us this. It is showing us that brightness is temporary, that beauty is temporary, that even the most spectacular arrangements of matter and energy will eventually dissolve into simpler states. And in showing us this, it is inviting us to appreciate the now, the present, the moment we are in. Because the now is when the stars are shining. The now is when the galaxies are spiraling. The now is when the universe is at its fullest and brightest and most alive with complexity. The now is the beautiful moment, and you are in it, breathing, thinking, looking up at a sky that will never be fuller than it is in this era. You are witnessing beauty in its prime, in its peak, in the window when it is most abundant. That's a gift, not a gift someone gave you, but a gift of existence, of timing, of being here when the conditions for beauty are at their best. Take a slow breath. Let that settle. Let it bring a sense of peace, of acceptance, of gratitude for the temporary nature of beautiful things. The stars will fade. The galaxies will dim. The beauty will pass. But right now, in this moment, it is here. It is alive. It is glowing. And you are here to see it. That's enough. That's more than enough. That's everything. Beauty is a temporary condition, and we are living in the beautiful moment. The moment when the universe, for a brief and precious window, is at its most radiant, its most complex, its most full of light and structure and the soft glow of accumulated stars. Rest with that. Let it fill you. Let it remind you that impermanence is not something to fear, but something to cherish. The beauty is passing, and that makes it beautiful. The universe is showing you its best face, its brightest self, its most luminous era. And it won't last forever, but it is lasting now. And now is all that matters. Now is the beautiful moment, and you are in it. And so we have traveled through the full arc. From the cosmic dark ages, when the universe was featureless and dark, through the blazing peak of cosmic noon, to the present moment when the total population of stars may be at its maximum, and ahead into the slow dimming of the far future. We have thought about what brightness means, how it can be measured in different ways, how it peaks at different times depending on what you value. And we have reflected on the temporary nature of beauty, on the fact that the luminous era we are living in is fleeting, precious, unrepeatable. Now it is time to come back, to return to the present, to this moment, to the quiet room where you are listening, to the night sky above you, real or imagined, to the simple fact of being here, now, alive in the brightest moment of the universe. Let us take a slow breath together. Feel the air moving in and out of your lungs. Notice the surface beneath you, supporting your weight. Let your body settle a little deeper, a little more fully into rest. You have been on a long journey tonight, a journey through billions of years, through darkness and light and the slow passage of cosmic time. But the journey ends here, now, in the present, where you have always been. And the present, as we have discovered, is extraordinary. You are living in or very near the peak of cosmic brightness. The universe holds more stars now than it ever has before or ever will again. The night sky, if you could see all of it from every point in space, is at its fullest. The lights are on, all of them. The cosmic stage is crowded with actors, with suns burning across billions of galaxies, with nebulae glowing, with star clusters shining, with all the accumulated light of 13 billion years of star formation. This is your moment, not in the sense that it was made for you, but in the sense that you are here to witness it. You exist during the brightest era, the most luminous window, the time when the universe is at its most radiant. And you can see it. When you look up at the night sky, whether from a city where only a handful of stars are visible or from a dark place where the Milky Way stretches across the heavens like a river of light, you are seeing the brightness. You are witnessing the peak. Every star you see is part of this moment, part of the accumulated population that has built up over billions of years and may never be larger than it is now. The stars you see are not eternal. They are temporary participants in a cosmic story, burning for a while before fading, adding their light to the total while they can. And the total, right now, is as high as it will ever be. That knowledge changes things, doesn't it? The stars become more than distant points of light. They become evidence of a peak, proof of a golden hour, reminders that you are living in a special era not because the universe arranged itself for you, but because the timing happened to work out this way. And that timing is a kind of gift. You did not choose when to be born. You did not select this moment in cosmic history. But here you are, living in the brightness, able to look up and see the universe at its fullest, able to know that this moment is the peak or close enough to it that the difference does not matter. So what do you do with that knowledge? How do you hold it as you drift towards sleep, as you move through your days, as you look up at the sky and see those distant suns? Maybe you do not have to do anything. Maybe it is enough to know, to carry the awareness that the brightness is temporary, that the lights will not stay on forever, that you are witnessing something fleeting and precious. Maybe that awareness brings a kind of peace, a kind of presence, a way of seeing the world that's colored by gratitude and wonder. Because the alternative, not knowing, means taking the brightness for granted, seeing the stars as eternal fixtures, unchanging and unremarkable, but knowing that they are temporary, that the universe is at its peak, that the lights will one day go out. That changes things. It makes the stars more vivid, more meaningful, more worthy of attention. You are not just looking at stars. You are looking at the brightest moment. You are witnessing the peak. And that makes every glance at the night sky an encounter with something rare and fleeting. This is not meant to make you sad. The impermanence of brightness is not a tragedy. It is the nature of things. Fires burn and then go out. Light shines and then fades. Stars are born and then die. That's how the universe works. And there's a kind of beauty in that cycle, in that arc from darkness through light and back to darkness. We are in the light, and that's all that matters. That's all we need. Take another slow breath. Let your thoughts settle. Let the journey we have been on tonight begin to fade into the background, leaving only the essential truth. You are here, now, in the brightest moment. And the universe, vast and ancient and temporary, is shining around you, holding you in its light. The future dimming is real. It is happening, but it is so slow, so patient, that it does not touch you. You will live your entire life in the light. So will every human being who has ever existed or ever will exist. The brightness is not fading on timescales we can perceive. It is fading on cosmic timescales, over trillions of years, far beyond anything we can imagine or experience. So you are safe. You are sheltered. You are living in an era when the stars will keep shining for as long as you need them to, for as long as your species needs them to, for as long as life on Earth endures. The brightness is temporary, but it is lasting now. And now is where you live. Now is all you have. And now is bright. Now is full. Now is the peak. Rest with that. Let it bring comfort. The universe is not fading around you. It is shining. The stars are burning. The galaxies are glowing. And you are here, in the middle of it all, part of the brightness, connected to it by the simple fact of existence. You are made of the same atoms that make stars. The carbon in your cells, the oxygen in your blood, the calcium in your bones. All of it was forged in the cores of dying stars billions of years ago. You are not separate from the brightness. You are part of it. You are stardust, animated, conscious, able to look up and recognize the light that made you. And that light is at its peak. The universe that forged you, that made the atoms you are built from, that scattered them through space and allowed them to gather into planets and life and consciousness. That universe is at its brightest right now. It is at the moment when it holds the most stars, the most light, the most potential for complexity and beauty. You are living in the fullest moment, and you are made from the stars that fill it. That's a profound connection, not metaphorical, not poetic in the sense of being untrue, but literal, scientific. You are star stuff, and the stars are at their peak. So when you look up at the night sky, you are not looking at something separate from yourself. You are looking at your origin, your source, the furnaces that made you. And those furnaces are shining more abundantly now than they ever have or ever will. You belong to the brightest moment, not as an observer from outside, but as a participant from within. You are part of the story, part of the light, part of the temporary, beautiful arrangement of matter and energy that makes up the universe in its most luminous era. Let that thought hold you as you drift toward sleep. Let it bring a sense of belonging, of connection, of being exactly where you need to be in time and space. The universe is bright, and you are in it, part of it, made from it, witnessing it from the inside. The stars above you, whether you can see them or not, are burning in their billions, in their trillions, across the observable universe. And they are burning now, in this moment, at the peak of their collective abundance. The night sky is full. The cosmic stage is crowded. The lights are on, and you are here, breathing, thinking, resting, held by the light of a universe at its brightest. There's nothing more you need to do, nothing more you need to understand. The journey is complete. The question has been answered. Are we living near the brightest moment of the universe? Yes, yes, we are. By many measures, by the measures that matter, we are living at or very near the peak. The most stars, the fullest sky, the richest, most complex, most luminous era the cosmos will experience. And that makes this moment, your moment, a gift. The gift of being here when the lights are on. The gift of witnessing the peak. The gift of living in the golden hour of the universe, when the brightness is at its fullest and the sky is at its most rich with stars and the cosmos shines with accumulated light. You are living in the brightest moment, and it is beautiful, and it is temporary, and that makes it more beautiful still. So rest now. Let your body settle completely. Let your mind drift. Let the thoughts we have shared tonight fade into the background, leaving only a gentle awareness, a quiet knowing that you are part of something vast and luminous and fleeting. The universe is bright, the stars are shining, and you are here, now, in the middle of it all, breathing under a sky that will never be fuller than it is in this era. That's enough. That's everything. Good night. Sleep well, and know that the light, the brightness, the fullness of the cosmic moment holds you gently as you rest. The stars are still burning. The universe is still shining, and you are part of it, part of the brightest moment, part of the temporary, precious, luminous now. The lights are on, and you are here to see them. Good night.